Hello guys, today we'll see in the lab about the calibration of the Congo Red dye, which is the azo dye, or you can say the anionic dye, which was discovered by the Paul Boettinger while working in the chemistry, and he was a dye chemist. And this is the first direct dye, and this is also called the azo dye. It has an azo structure. It is water soluble, but it has solubility greater in the organic solvents. And this is the you can see the formula of this, and this the molecular weight is around 696.665 gram per mole, and this is sodium salt of benzidine biso bis 1 naphthylamine 4 sulfuric acid, which is red in alkaline medium or basic medium, blue in acidic medium. So usually the working range for adsorption studies is from 5 to 10. Okay, and it is an indicator in biological stain, and you can see the structure is like this, which is complex. Okay, and let's see how we perform the calibration of the Congo Red dye, okay, in the laboratory using our UV visible spectrophotometer. And we have earlier saw a lot of videos in my channel related to its calibration. Okay, we are going to learn the calibration of the dye, which is Congo Red, and this is anionic. Okay, so let's start first of all the weighing. This is now tiered. Okay, now add a very small amount of dye
using this side?
Yeah, spatula, yes, of course, very small. Just when you add a pinch of salt, right? It's such a amount, more or less, or
More?
yeah,
Like this?
small, just cut it down.
Okay.
Just very small amount. Yeah,
Okay.
it's okay. So the add on the paper. Okay, just wait. It is how much amount? Add more.
17.
Yeah, just the amount you took, add more. So let's weigh around maybe 30-40. Okay, yeah, more. Yes, just wait. More. Okay, just wait. Okay, just close. So this is around 45. You can say 45.16, so it's around 45 ppm. Okay, so just close the die. Close. And now what we need to do is to transfer this to the jar. Okay, let's transfer. Take it out.
Which one?
This is transferred. Okay, now we will add deionized water and shake it for around half an hour. Transfer. Okay, so you will you're pouring around 500. We need more 500. Okay, so now trying to shake slowly. Add more. Yes, more. More 500. Okay, more 500. Okay, so this is around 1 liter. Okay, okay, no problem. Can you remove the funnel, and then you should cover this. Okay, let's leave it. Cover this. Okay, cover with aluminum foil, even the top, and then we'll wait for around half an hour. Okay, around half an hour. So our this is well mixed. Okay, Congo Red. Now this is our, what is this, students? Is our serial dilution. So from 45 ppm we had made around how many lower stocks? So this is 30 ppm of Congo Red, 20, 10, 6, 3, 2 and 1. Now you can come closer and then see how we make the calibration. So for making the calibration, we'll go here and then we'll say program options and then edit. Okay, sorry, not this one. Program options and new. Now this is a program number, leave it, and then you can go okay, come here, and then you need to type here, let's suppose Congo space and then red. Okay, next is what you want to do. This is single multi-phi, so usually we say single wavelength. Next, and then milligram, what this is gram per liter, this is milligram, so this is our milligrams per liter. Or can you also measure gram per liter, also micro, also nano, also ppm, also pp. Next, now what is the wavelength? Okay, for wavelength we need to scan it. Okay, so let us first of all come out. We can just cancel it. Let's store, we can play with later on. Come out, exit. So for scanning, what we need to do is wavelength scan. Okay, now for zeroing, what we need to do, we need to put a vial which has just water, nothing else. So let's suppose this is my vial with water, and then we need to zero. So when you zero, okay, there is a wavelength, sorry, there is a line which will be straight. When there is water, there is no peaks, so it will be straight.
Can we try something else?
What is that?
I'd like to see the wavelengths.
Yeah, I will just show you, just wait. Okay, so first now we have put the Congo Red, and then you will scan, read. Usually when you put the color first, so this is your unknown. Okay, so there should be a reference, so usually water is a reference. Okay, so you can come and see there is a peak now coming up. See, there would be peak. See, okay, now it identifies the color, so based on the wavelength. Okay, now we will find out the maximum wavelength from here, the one we have to put there in our calibration window. So you can just put here. So what is the maximum wavelength? Is around 496. So this is my maximum wavelength for the Congo Red dye. Yeah. Now I will come out of the window, and then I will go to my usual program. This is my Congo Red. I'll choose program, and then I will edit. So I have to edit this one, edit. So this is how much, students? 496. Okay, now I will edit my calibration. So read standards. So you can put first of all 0, first 0, 1, then 2, then how much? 3, then 6, 10. Minimum, how many points for calibration? 3. Minimum is 3.
Then 20 and 30.
Yeah, let's try how much it can go, because there is a limit also how much it can weigh. Read. So now we'll start first of all with 0. So first, this is my 30. So water here, then 0, again the same one we will read. So it's showing -1. Okay, now we need to first now transfer this 1 to the vial. Okay, you can transfer. Come ahead and transfer to this vial, clean vial with the micro pipette. This is my clean pipette. Transfer 1.
From 1, right?
Yes, from 1, carefully. Around 2 ml. We need around 2 ml to measure. Okay.
Okay.
Yeah, it's okay. Just transfer. Vial here, and then close, and then just read, not 0. Read. Press read. Okay. So it is here how much? 0.11. Now discard this and add from the 2 ppm. Okay. This is 2 ppm, right? So now read. Ideally, if the 1 ppm shows 0.11, so 2 should show double. So it's almost double. Okay. Now 3. In the surface of the vials also, and there should be no thumb impression. Okay, on the vials. Okay, now put them inside the holder. Close your UV and then read. Okay. Yes. So it's there is a problem. You see.
Yeah, it should be 3 times
No problem.
1.
No problem. Throw it away. We can discard some points later on. Okay. So yeah, we are testing again 2, right? Just so this is 3. So again we will check. Okay, so it's not changing. No, let's try 6 ppm. So for 6 ppm, so which is how much? I mean it's okay. Now try 10 ppm please. This is 10 ppm, right? Close and then measure. Okay, now 20. Okay, close and then read 20. So this is how much? Okay, now try 30. This is how much? Students, 30, right?
Yes.
Okay. Okay, now let's check the calibration. So it's showing 0.9966. Let's go back and identify the points which are wrong. Okay, we may delete. So this is what? How much? 0.11. This is double, and this is not.
Right.
I mean triple. So we can delete it. And this is how much? So if you compare with this one also,
It should
it's
be
like
times 3.
6 times from this one, right?
1, yeah.
Yeah. So let's check again. I mean showing correct, but we can delete. And what about this one? Even this is also not okay. But anyway, it's okay. So go and check. This is 0.9964. Okay.
Yeah.
So done. Store. Exit, right? Now this is ready for measurement. So go and then let's suppose this is what? 30. Hold this please in your hands. Don't throw it. Then try this one 0. Okay, then check this one please. This is your unknown. And then read. So it's around 30, right? So okay, now there is one more question to all of you. If suppose this is now maximum, we went in the calibration till 30. If suppose you have 100, you have 200, what will you do in that case? Because your machine will not read that. What will happen? In that case, it will show absorbance value greater than. So in that case, you need to dilute. Suppose you have 100 ppm. So in that case, you will be diluting since you are going till 30. So you will dilute 3-4 times.
Yeah.
So whatever values, whatever times you have diluted and whatever value you have got, you need to multiply that value with the number of dilutions.
Yeah.
So this was all about the calibration of the Congo Red, which is an anion dye using the UV visible. Now this has been done at suppose neutral pH. Suppose you are changing the pH. In that case, the wavelength will shift. It won't be 496 since this is at pH 6, for example.
Yeah.
Suppose you are doing your studies, absorption studies at pH 8, pH 10, or pH set. Suppose pH 4 or pH 5. In that case, there would be a wavelength shift. Okay, the wavelength would not be the same. So in that case, you should make your calibration at all pH to minimize the error.
Yeah.
Okay. One thing more I forgot to explain with all of you. See, this is my acid, right? So usually working with the Congo Red dye is not okay to go below 5. When you go below 5, what happens? This dye precipitates. You see, this is my 0.1 normal HNO3. So when I am adding this, see what happens here. You see now color change. So it's not okay to work in the highly acidic range. So you should work with this dye from pH beyond 5. Usually I prefer to work from 5 to 10. Not in the highly acidic range, not in the highly basic range. You see now, for all you see, change. All change. Because right now the pH will be around 5 to 6. So if you are going from below 5, so how will it identify? It will not identify this.
Yeah.
Because your the color was red, round red orange, and it became totally blue after adding acid, right? Okay.